Cartesian product of sets. Let A and B be two non-empty sets. The set of all ordered pairs ordered by AB such that A element of A and B element of B is called the Cartesian product of the set A with set B and is denoted by A cross B. That the definition everybody knows it. Let us have one example. Let A is equal to set 1, 2, 3 and B is equal to set A 2, 5, 8, 6. Now the Cartesian product of A and B is A cross B. It is a set of all ordered pairs 1A, 1B, 2A, 2B, 3A, 3B. This we have studied in 11th class. A is having 3 elements, B is having 2 elements. So the Cartesian product A cross B is having 6 elements. So very simple. Now let us think about the Cartesian product of a closed interval and a set of all real numbers. Closed interval minus 1, 1, say for example, and set of all real numbers. Otherwise, the Cartesian product of R cross R. We know that set of all real numbers is uncountable. What will be the Cartesian product? Let us see with the help of GeoGebra. So this is the Cartesian plane, x-axis and y-axis. R cross R. So first set of all ordered pairs in which the first element or x-coordinate is elements from x-axis. And the second component or second coordinate is numbers of y-axis. So R cross R is the set of all points in this Cartesian plane. It means that every point in the Cartesian plane is a point in the Cartesian product R cross R. Let us have one example. Cartesian product of set 1, 2 and set 3, 4, 5. It is 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5. That's it. Now, these ordered pairs can be plotted in this plane. You can see that it is 1, 3, 1, 4, 1, 5 and 2, 3, 2, 4, 2, 5. And this point, we can move anywhere in this plane and we are getting real numbers as the first component and real numbers as the second component. So that is R cross R, set of all points in R cross R. So very clear. Let us think about the Cartesian product, a closed interval and set of all real numbers. Closed interval minus 1, 1 cross R. Here, the collection is a set of all ordered pairs in such a way that the first component is an element of minus 1, 1 and second component is an element of the real number set R. What will be that? Let us see. It is this strip. In this blue color strip, all the points in this strip are points on the set minus 1, 1 cross R. Closed interval minus 1, 1 cross R. Let us think about another example. R cross closed interval 0, 2. Here, the set of all first components, ordered pairs in the set of all ordered pairs of the first component are elements of the real number R, and the second component of the ordered pairs are elements of the closed interval 0, 2. It means that the x coordinate or first component are elements of this real line, and second component are elements on the closed interval 0, 2 means from 0 to 2. What will be that? That will be the strip, this pink cluster. All the points in this region, colored region, will be the point on the Cartesian product R cross 0. Now, let us think about the Cartesian product of two closed intervals. I am taking the intersection of these two, that is a closed interval -1, 1 cross closed interval 0, 2. What will be the Cartesian product? That Cartesian product will be the intersection of the previous two cases. That is this one. So all the elements in this region are elements of the Cartesian product -1, 1 cross 0. Now it's clear. Now this is Cartesian product. Now we have to define a relation. What is a relation? In our life, we are having so many relationships. Let us connect the relationship to mathematics here. Let us see. There is a situation. Suppose in a Vidyalaya, there are some teacher set and some student set. I am taking T as the, let me take a different one. I am taking T. T is the teacher set. The teacher set T contains teacher 1, teacher 2, teacher 3. I am taking the student set S is equal to student 1, student 2, student 3, student 4. And some other informations also available. The informations are teacher 1 teaches student 1, student 2 only, because different subjects are there. Teacher 2 teaches student 1, student 3, student 4. And teacher 3 teaches student 2 only. A sample is given. The information given here is, now I am putting it into a set form, roster form. So let R be the relation. Another given as a, let R be a relation from T to S as given as defined as teachers. This is the relation, teachers. Now I just want to write this R in roster form with this available information. So what will be that? That will be R is equal to such a form. Teacher 1 teaches S1, So I can write as ordered pair T1 S2. Teacher 1 teaches S2, student 2. So ordered pair T1 S2. Teacher 2 teaches S1, S3, S4. So I can write as T2 S1, T2 S3, T2 S4. Teacher 3 teaches student 2. So T3 S2. So this is the relation as per the given condition. Let us think about the Cartesian product of T and S, T cross S. The Cartesian product of T cross S will be, everybody knows this, ordered pair T1 S1, ordered pair T2 S2, T1 S3, T1 S4, same way T2, same way T3. So we are getting a collection of ordered pairs. You think about that T cross S and this R. Every element of this set R is an element of T cross S. If every element of a set is an element of T cross S, then this will be a subset of T cross S. So what we are getting? This relation R is a subset of T cross S. It means that a relation from T to S is a subset of T cross S. So the relationship in our daily life just connected to mathematics now. So that is the definition of relations. Relation. Let A and B be two sets. Then a relation R from set A to set B is a subset of A cross B. Just we have discussed. Thus R is a relation from A to B, then implies an implied way R subset of A cross B. Suppose ordered pair AB is element of R. It means that A is related to B under the relation R. Then we can write this as this ARB. ARB means ARB. It implies A is related to B. So if ordered pair AB element of R, then ARB implies A is related to B. Now, my question, another question, that is, suppose A is a finite set containing M elements and B is a finite set containing N elements. Then, how many relations are possible from A to B? We just connect it with our 11th class power set. If A is a set, then the set of all subsets of A is called a power set, and power set contains 2 raised to number of elements in A. We apply this here. So, number of relations from A to B will be equal to 2 raised to number of elements in A cross B. Number of elements in A cross B is M into N. So, the number of relations from A to B is 2 raised to Mn, where M is the number of elements in A and N is the number of elements in B. Domain of a relation. Domain of a relation is the set of all first components of the ordered pairs in the relation R. That is, let R be a relation from set A to set B. Then the set of all first components or coordinates of ordered pairs belonging to R is called domain of R. Clearly, domain of R, subset of A. Now, range of a relation. Range, let R be the relation from set A to set B, then the set of all second components or coordinates of the ordered pairs belonging to R is called the range of R. Clearly, range of R will be a subset of set B. Range of R is a subset of set B. Now, relation on a set. What is relation on a set? A relation from a set A to itself is called relation on A. In short, a relation on a set A is a relation from A to A, that is subset of A cross A. A is a non-empty set, then the relation from A to itself is called relation on the set A. Now here we are discussing, in our class 12, we are discussing relation on a set A generally. Okay? Now, what is inverse of a relation? All these things we have studied in 11th class. Inverse of a relation. Let R be a relation from A to B. A and B2 sets, R be a relation from set A to set B. Then, the inverse of R, denoted by R inverse, R is to minus 1, it is R inverse, is a relation from B to A and is defined by R inverse is equal to set of all ordered pair AB such that AB element of R. So, what are the elements, ordered pairs belonging to R? Write that ordered pairs in reverse order. That is, the first component becomes second component and second component becomes first component. Then that relation is called the inverse of the relation R. Clearly, AB element of R implies and implied by BA element of R inverse. Now, let R be a relation defined on set of integers defined by ordered pair xy element of R implies and implied by x square plus y square equal to 60. Right, the relations R and R inverse. Relation R is the set of all integers satisfying the conditions x square plus y square equal to 60. So, we can write that. R, what will be R? R is equal to ordered pair xy belonging to R if x square plus y square equal to 60. Let us take x is equal to 0, one integer I am taking as x equal to 0. When x equal to 0, y can be, because x square plus y square equal to 16. So, when x equal to 0, y square will be 16, means y can be 4 or minus 4. So, 0, 4, otherwise 0, minus 4. Now, if you give x is equal to 1, it's not possible because 15 square root is not an integer. If you give 2 square 4, it is 12, it is not possible. If you give 3, then also it is not possible. Now, we can give x is equal to 4. When x is equal to 4, it becomes 16 plus y square, then y should be 0, then only 16. So, x can be 4 and x can be minus 4, whereas y will be 0 in that case. So, the ordered pairs are 4, 0 and minus 4, 0. So, this is the relation R. Now, we have to write R inverse. R inverse is equal to, just reverse the ordered pairs. So, here become 4, 0 and this become minus 4 0 and here become 0 4 and this become 0 minus 4. Dear children, here there is no distinction between R and R inverse. Because it is symmetric, x square plus y square equal to 16 can be written as y square plus x square equal to 16 also. So there is no distinction between R and R inverse in this particular case. And here, what is the domain of R? Domain of R, the relation R, the set of all first component. First component is 0, 4, minus 4. So they can write it as minus 4, comma 0, 4. And what about the range? Range is the range of R. Range of R is the set of all second component. And the second component has 4, minus 4, 0. So it's 80. Minus 4, 0, 4. So domain of R and the range of R are both in here same. So these are the things what we have studied in class 11. Now we have to discuss different types of relations that we can discuss in the next session.